Hello and welcome to lesson 2 of module 8. We are going to start to multiply radicals together. So the learning target for today is multiplying two radicals and expressing the answer in simplest radical form. So a reminder, I showed you this property in the last lesson. For positive numbers a and b, if you multiply them together, you can separate them into two radicals. Well, the opposite of that is also true. If I have two separate radicals and they're multiplied together, I can put them together under one radical. Okay, so what I could do here is I could multiply 18 times 10 and say the square root of 180. I can do that. I'm not going to, though. What I'm going to do is I'm going to break down 18 and 10 into under one radical. So I'm going to put a big radical there. 18 is 9 times 2. 10 is 5 times 2. Now, if I rewrite that as terms of something squared, 9 we should know is 3 squared. 2 times 2 is 2 squared. And then we got a 5. So the square root of 3 squared is 3. The square root of 2 squared is 2. And the 5 is left under the radical. So 6 radical 5. All right. What about this one? We got some numbers already on the outside and 6 and 15 underneath the radical. So what I'm going to do is I'm going to look at the 4 radical 6 first. The 4 is already on the outside. I'm going to leave it there. 6 can be broken up into 3 times 2. 10 is already on the outside as well. So I'm going to leave it out there. 15 can be split up into 3 times 5. Now, why break them down like that? Well, now I can put the 3's together and say 3 squared. Notice what I did with the 4 and the 10. They made 40. The 3 times 3 makes 3 squared. The 2 is unpaired, and the 5 is not paired. They don't have a squared there. So now I can take the square root of 3 squared, which is 3. The 2 and the 5 can multiply together to give me 10 back under the radical. They didn't cancel the radical because there wasn't a squared. All right, so last step is just do 40 times 3, which is 120, radical 10. What about this one? 3 radical 7 squared. Well, what I'm doing is I'm doing 3 radical 7 times 3 radical 7. So I'm doing 3 times 3 on the outside, which is 3 squared. And I'm doing radical 7 times radical 7, which is the radical 7 squared. The 3 squared is 9. Radical 7 squared. The radical and the squared cancel, and I'm left with just 7. Not 49. 7. The radical and the squared cancel, and I'm left with just 7. 9 times 7 is 63. Find the area. This is a pretty challenging problem just because of how the length and width are. Reminder that area is length times width. So we're going to do 2 square root of 12x squared times 4x to the third, 6x square root of 6x to the seventh. So I can put the outside stuff together. So the 2 and the 4x to the third can get multiplied together on the outside. Underneath the radical, I'm going to break the 12 down into 2 and 6. I know I could break 6 down further, but I know that I have a 6 in the second part, in the green. And so I know that the 6 can combine with the other 6. I see that. And so I'm going to break the 12 down into 2 and 6. X squared is just x squared. It stays there. 6x to the 7th, I'm just going to leave the 6 alone. And then x to the 7th, I can do x to the, I'm going to be combining that with the x squared. So 2 times 4 is 8, x to the third. That's on the outside. Under the radical, 2 does not have a match, so it's just 2. 6 does have a match, so I can write that as 6 squared. And then I can do x to the 8th and x. Now, why x to the 8th? If you haven't noticed yet with variables, you can divide the exponent by 2, right? Because I could write x to the 8th as x to the second, x to the second, x to the second, x to the second. That's 4 of those. So I would have 4x to the seconds, which would mean I would have 4 x's that can be brought out. So you'll see that here in the next step. 8x to the third is already out there. Radical 6 squared is just 6 on the outside. X to the 8th is x to the 4th, like I just talked about. I can make 4 pairs of x's from 8 x's. The 2 and the x remain inside the radical. Last step is just to multiply what's outside, what was already outside, 8x to the third, times what got brought out. So 6x to the 4th. 8 times 6 is 48. X to the third times x to the 4th is x to the 7th, radical 2x. So the area of that rectangle in simplest radical form is 48x to the 7th, radical 2x. And that concludes our lesson on multiplying radicals.